In this video, I will discuss one of the important group transfer reaction, Ene reaction among pericyclic reaction. I will discuss the mechanism, FMO method of group transfer reaction, intramolecular Ene reaction, carbonyl Ene reaction, mechanism of carbonyl Ene reaction, intramolecular carbonyl Ene reaction, and examples in this video. Okay, let us discuss group transfer reaction in more details. Group transfer reaction are a kind of pericyclic reactions where one or more groups or atoms gets transferred from one molecule to another. Like all the other pericyclic reaction, they follow the conservation of orbital symmetry rules. That is Woodward-Hofmann's rule. Ene reaction among the group transfer reaction is the most studied example. The thermal reaction between an alkene which has an allylic hydrogen known as Ene with a compound containing a multiple bond, that is enophile, is known as Ene reaction. It is similar to Diels-Alder reaction in respect of the reaction between Ene and an enophile. Thus, Ene reaction is often referred to as Alder Ene reaction because it is similar to Diels-Alder reaction. Okay, they resemble 1,5 sigmatropic rearrangement since a sigma bond moves, and they also resemble cycloadditions like Diels-Alder reaction as we have discussed, with one of the pi bond of the diene being replaced by a sigma bond. Nonetheless, since the reaction is bimolecular and no ring is formed, they are neither sigmatropic shift nor cycloaddition reaction. You might have studied sigmatropic rearrangement is a monomolecular rearrangement. It is not a bimolecular rearrangement. But Ene reaction is a bimolecular rearrangement. Here there is no ring is formed, and hence it is not like a Diels-Alder reaction. And hence we can say they are neither sigmatropic nor cycloaddition reaction. See, for example, it is the example of an Ene reaction. Here hydrogen gets shifted from this Ene to this enophile like this. Thereby these molecules are formed by the Ene reaction. It is a typical example of an Ene reaction where hydrogen shifts takes place with the shifting of this sigma bond to between this carbon atom and the shifting of pi bond to this carbon atom. Thereby this molecule is formed along with this isomer. That is an example of Ene reaction. Another example, in presence of a Lewis acid. Here capture of this hydrogen by this carbon atom takes place, or migration of this hydrogen to this carbon atom takes place with the shifting of this sigma bond to sigma bond between this carbon atom along with the bonding between these two carbon atom by using this pi bond, forming this molecule. It is another important example of Ene reaction where aluminum chloride, that is a Lewis acid, which acts as a catalyst. Okay, as in the case of Diels-Alder reaction, electron withdrawing groups on the enophile and the electron donating groups on the Ene favor the reaction. Lewis acid catalysts such as aluminum chloride has also seen to lead to rate enhancement for Ene reaction that we had already discussed. The Lewis acid catalyst reaction afford high yield and selectivity at a significantly lower temperature, making the Ene reaction a useful carbon-carbon bond forming tool for the production of natural products. Okay, in general, Ene reaction, a hydrogen atom moves from the Ene component to the enophile, but other atom can also move equally well in principle. That means usually a hydrogen atom moves from the Ene component to enophile, but other atom may also move in certain Ene reactions. Then next we will discuss frontier molecular orbital method of Ene reaction. As we have already studied, frontier molecular orbital method is HOMO-LUMO interaction. Here HOMO of the Ene interact with the LUMO of the enophile, forming the product. Here it is a typical Ene reaction where hydrogen shifts takes place from the Ene to enophile. Then the HOMO of the Ene HOMO of the ene interacts with the LUMO of the enophile, where you can see the in-phase interaction. Both the lobes are equivalent. See, similar lobes are interacting, thereby the product is formed. An example for the Ene reaction. See, here hydrogen shift takes place. The reaction takes place in Lewis acid. This Ene reacts with this enophile. You can see this enophile has an electron withdrawing group. Then this Ene having an electron donating methyl group. The reaction takes place in Lewis acid. So the reaction will be very fast. And so the interaction takes place like this. The hydrogen migration you can see from the ene to enophile takes place, thereby forming this product. Okay, now let us discuss some of the important examples of Ene reaction. See this Ene reaction. This Ene reacts with this enophile in presence of this ethyl aluminum chloride, that is a Lewis acid. Then you can see the Ene containing the electron donating groups, methyl groups in both the ends of carbon-carbon double bond, and here is an electron withdrawing group in the enophile along with this Lewis acid, and so the reaction will take place very fast, forming the product. See the migration of hydrogen from ene to enophile, then bond shifting, forming this product. Then another example. See in this example also, here is an electron donating group, methyl group in ene, that enhances the rate of reaction, and also it is malic anhydride. This anhydride group is an electron withdrawing group in the enophile that also make the reaction faster, and hence this product is formed after the Ene reaction. See another example. It is another example. This Ene reacts with this enophile, forming this product. You can see the migration of this hydrogen to this position, and this enophile containing, you can see the electron withdrawing group. Then the reaction takes place to form this product. Okay, then another important reaction is this. Here also there are two methyl group. The hydrogen shifts from ene to enophile. This enophile containing the ester group, electron withdrawing group, forming this product. Another example is this, and this group, the butyl group, an electron donating group that is present in the ene, and this enophile you can see containing two ester groups attached to this unsaturated acetylenic carbon atoms, and hence the reaction will be fast, and hence this product is obtained after the Ene reaction. See another example. This is a natural product. One of the important application of Ene reaction is it is used to produce some natural products by hydrogen shifts or the shift of other atoms. You can see hydrogen shifts takes place from this molecule. It acts as an ene, and it is the enophile. Thereby this product is obtained. It is our last example. Then you can see it is the ene, it is enophile. Then hydrogen shifts takes place from this carbon atom to this carbon atom, followed by the shifting of these pi bonds, and a new sigma bonds are formed. Then you will get to these products. These are the important examples of Ene reaction, very important examples. Okay, intramolecular Ene reactions are another important set of reactions that benefits from the less negative entropies of activation as compared to their intermolecular counterparts. Intramolecular Ene reactions are more facile, occurring even in the case of simple enophile, even without any electron withdrawing group, such an unactivated alkene and alkynes, and are highly regioselective and stereoselective. See, for example, it is an example of intramolecular Ene reaction. Hydrogen shift to this enophile component of the same molecule. Here this part acts as enophile and this part acts as Ene. From the Ene part, hydrogen gets shifted to the enophile part or enophile component of the same molecule. Thereby intramolecular Ene reaction takes place to form this product. Similarly, this molecule, here it is the Ene part, it is enophilic component of the same molecule. Hydrogen shifts from this ene part to enophile part, thereby this product is obtained. Similarly, see here also the hydrogen is shifted from this carbon atom towards the enophile component to the atom Y, thereby this product is obtained. It is another intramolecular Ene reaction. Similarly, in this molecule also, intramolecular Ene reaction takes place. Hydrogen shift takes place from this carbon atom to this carbon atom of the enophile component. Thereby this product is formed. Another important intramolecular Ene reaction is this. Here this reaction takes place in presence of methyl aluminum chloride, a Lewis acid. Here it is the Ene component and it is the enophile component of the same molecule. Then you can see the hydrogen shifts from this Ene component to enophile component that takes place to form this molecule. It is the final product of this reaction. Okay, carbonyl Ene reaction is an important type of Ene reaction in which hydrogen shift takes place from an Ene to carbonyl oxygen of an enophile. See, for example, it is an Ene. This hydrogen shift from the Ene takes place the carbonyl oxygen of this enophile, forming this product. And this reaction is called carbonyl Ene reaction. See another example. Here it is the enophile and it is the Ene. See, the hydrogen shift from this Ene takes place to the carbonyl oxygen of the enophile. It is enophile. It is the carbonyl oxygen. Here this hydrogen shifted to this oxygen, forming this alcohol. Okay, and these are some of the important examples of carbonyl Ene reaction. Okay, if the hydrogen shift from the Ene taking place to the carbonyl oxygen atom from within the molecule itself, then it is called intramolecular carbonyl Ene reaction. See, for example, in this molecule, a hydrogen from this carbon atom shift to this oxygen to form the product. Here it is an example of intramolecular carbonyl Ene reaction. A hydrogen from this carbon atom to this oxygen takes place, forming this product. It is an example of intramolecular carbonyl Ene reaction. You can see hydrogen shift takes place from within the molecule to the carbonyl oxygen. Then this product, upon reduction in presence of nickel, thereby this double bond gets hydrogenated to form the menthol. That is, it is a way to convert R-citronilal to minus menthol. Citronilal will be converted into menthol via intramolecular carbonyl Ene reaction. Okay, another example of carbonyl Ene reaction is this. Here one of the hydrogen from this methyl group, you can see from methyl group, gets shifted to this oxygen, carbonyl oxygen, whereby this pi bond shift in between these two carbon atom, thereby ring closure takes place, ultimately forming this product, this alcohol, by the carbonyl Ene reaction. Okay, so we have already discussed Ene reaction, its mechanism, intermolecular and intramolecular Ene reaction, carbonyl Ene reaction, its mechanism, intramolecular carbonyl Ene reaction, and some examples of Ene reaction, intramolecular Ene reaction, carbonyl Ene reaction, and intramolecular carbonyl Ene reaction. I think you might have got a clear concept about these Ene reactions. I conclude my video here. Thank you for watching. Thank you.